Okay, so looking at number 5, 6, 7, and 8, you'll see there is another keyword, and that keyword is or. And again, last class period, you learned the difference between and or. For these final answers, we're going to need to include any part of the shaded region. So any part of the shaded graphs that we shade on the first two, we're going to include those in our final answer. So we're going to solve these as usual, right? So notice even before with the ands, we solve these as two separate inequalities. So treat them as two separate inequalities first. So I'm going to divide that first one by -3. I get n is greater than or equal to 4. So again, think about why I switched the inequality sign. I divided by a negative. The second inequality, subtract 5. I get n is still less than or equal to -3. Now the key word here is or, right? So I'm going to graph the two inequalities first. So my two boundary points are -3 and 4. For the first one, n is greater than or equal to 4, so close circle to the right. N is less than or equal to -3, so close circle as well to the left. And now when I put these two graphs together for my final solution, or means anything that's shaded. So as long as it's in the blue area or the red area, it goes on my final graph. So that means I'm just going to basically transfer each of those shaded regions down to my final graph. So both of those become on the same number line. So that means my solutions are anything that is in the red or the blue is part of my final answer. Okay? Number 6, notice fractions. Remember, these are same as if we were solving equations. Deal with fractions for the first one. I'm going to multiply everything by 6. And that means I have m is less than -6. For the second one, multiply everything by 4. Notice again the fractions, boom, they're gone. They cancel out. And I multiplied by just positive numbers, so no inequalities switching directions. Again, the key word is or. Make sure you bring that down in between. That way you remember what the final solution needs to represent. So let's go ahead and set up our number lines. This one again, make sure with negative numbers especially, make sure you do have those in order, right? So -6 is on the left side of -4. So when I set that up, I want to make sure I put -6 first. And then graphing those two original inequalities. So at -6 is less than, so open circle to the left. For my second one, m is greater than or equal to 4, so filled in and to the right. And then it's or. So that means my final two shaded areas are just everything that I've shaded already. I'm just putting it all in one graph to show it all nice and neat in one number line. So the other thing the key word we connected was anything or everything that's shaded needs to be included. Okay. Number 7 and number 8 are two other examples of what can happen with ors or compound inequalities. So let's take a look here. Again, solve the two inequalities separately on their own. So if you want to pause the video and try that on your own first, that would be a good idea. Otherwise, keep watching, follow along, fill in your notes. So subtract 6. I didn't switch the inequality sign yet. There's no need. I'm going to divide by +5. And I'm still not switching the inequality sign because I did not divide by a negative. Similar steps for the second one. We get 3x is less than or equal to 30. Divide by 3. I get x is less than or equal to 10. Again, just remember, this is an or. So that means I'm going to graph the two inequalities separately. Two boundary points are -5 and 10. On the first inequality, x is greater than or equal to -5, so filled in circle to the right. X is less than or equal to 10, so filled in circle to the left. You may be asking yourself how I decide which one to graph on which inequality line. It doesn't matter. I could have put the blue one on the second line, the red one on the first line. I would still end up with the same result. And in this case, just remember, our final solution is or, so that means anything I've shaded on either of the previous two needs to be included. So I'm just going to transfer both these down here. And notice what happens on this one. Think about that number line. Everything is shaded on that number line. So for this one, this would be a good example of when we get an all real solutions or all real numbers. The whole number line is shaded. Okay, so everything works for that. Let's take a look at the last one here, number 8. Again, solving this. You want to try this on your own first, then watch the video, see how you did. Do that. Otherwise, let's see, we get 61 minus 7 is 54. Divided by 9, we get x is less than or equal to, got the equal to up above, 6. And then for the second inequality, subtract 6. And divide by -2. So x is less than -6. So that inequality sign switched directions. Okay, so or still what we're looking at. So our two boundaries are -6. Again, make sure you put the numbers in order. The two boundary points need to be in order as they would appear on a number line. And then from there, it doesn't matter. If I put the blue one on the second line, it doesn't matter. So let's do that. So close circle and to the left, less than. For -6, it's also it's an open circle, and it's also to the left. And now, here's where we have to make sure, again, if you think about it as you just bring down everything you shaded before, because it's an or, everything you shaded before needs to be included. So there's the blue and then the red. Notice how the red shaded area is already included in the blue area. So we don't really need to shade each of those individually. We just really need to bring down the blue boundary point, so 6 is closed, and then shade everything to the left of 6, and that includes the red area already. So we don't need to we don't need to put the open circle where the -6 is, we just shade right through it. Okay, so for this one, number 8, there's your final solution.